this video, we are going to study one of the most important results in calculus, the Fundamental Theorem of Calculus. This theorem connects two major ideas: differentiation, which is the finding derivatives, integration, which is finding areas. By the end of this lesson, you will understand how these two are linked. Fundamental Theorem of Calculus. Fundamental Theorem of Calculus has two main ideas that we should look at. One, derivative, which is the rate of change. Two, integral, which is the total of accumulation. Before we go into formulas, let's understand the idea. The derivative is the rate of change, while integral the total of accumulation. The first part of the theorem says if we define a function as an integral, then its derivative gives us back the original function. F of x equal the integral a raised to the power x f of t dt. If we find the integral, the differentiation cancels integration. So if we integrate a function and then differentiate it, we will get the original function. Let's try an example to understand this better. Example 1. F of x is equal to integral from 0 to x t square dt. The first step, we have to integrate. Step 1, t square. When we integrate t square, our result will be t cubed upon 3. Then we have to apply the limit. Mind you, our limit is from 0 to x. When we apply limit from 0 to x, which is t cubed upon 3, 0 and x, the lower limit and upper limit. When substitute 0 with the t, this entire problem will be 0, the lower limit. Or substitute t with x, it will be s cubed upon 3. We have to find a derivative x cubed upon 3. To find the derivative, f prime upon x, which will be 1 upon 3. The derivative of x cubed will be 3x2. 3, we cancel 3. So our final answer will be x squared. Now we have the same function of t squared. We get x squared. Let's look at the second part. The second part helps us compute definite integrals easily. Integral a raised to the power b f of x dx equal to f of b minus f of a, where capital F of x is any antiderivative of f of x. This means to evaluate an integral, we just find the antiderivative and plug in the limits. Example 2. Let's apply the formula. Integral from 1 to 3 x squared dx. To solve this one, the first step, we have to look for the antiderivative. First step, find antiderivative. The antiderivative of x squared is equal to x cubed upon 3. Now we have to apply our limit. Our limit, the lower limit is 1, the upper limit is 3. X cubed upon 3, lower limit from 1 to 3, which is 3, substitute x with 3, 3 raised to the power 3 become 27, 27 upon 3, minus, substitute x with 1, it become 1 upon 3. 27 divided by 3 will give us 9, minus 1 upon 3. Our final answer will be 26 upon 3. This is our final answer. That's how we compute definite integrals quickly using the theory. Now pause the video and practice this problem. Integral from 0 to 2, 2x dx. Pause the video and solve the problem. Now to solve this problem, our first step, always we have to look for antiderivative. 2x is the same as 2x squared upon 2. 2 cancel 2, so our antiderivative will be x squared. Now we have to apply our limits. Our lower limit is 0 and 2. X squared, 0 and 2. When I substitute the x with 0, this entire problem becomes 0. When we take the upper limit to substitute with 2, your 2 squared will be 4. So our final answer will be 4. Let's summarize this problem. Fundamental Theorem of Calculus. Part 1, it is the derivative of an integral gives original function. For part 2, integral equal to f of b minus f of a. This theorem connects differentiation and integration, making calculus much easier. If this lesson helped you, please don't forget to like, share and subscribe to the channel. More calculus lessons are coming, including applications and advanced problems. Thank you for watching.